Okay, so the second part of the solutions lesson is going to talk about solutions of inequalities, which is what we learned yesterday, where you graph a line and you shade on either side of the line. So they also have solutions. It's kind of like a combination of solutions of a line and the combination of multiple solutions, like we saw with the solutions on the number line, where we have more than one answer that will work. So keeping that in mind, let's take a look at this graph where I have a solution of a linear inequality. My graph is y is less than or equal to x plus 2. So y-intercept of 2, slope of 1. So let's talk about what is and is not a solution of a linear inequality. So the reason you were shading yesterday, like in this yellow area that's shown on this graph, all the points in that yellow area will make this a true statement. Or I should say all of the points in the yellow area are solutions to this inequality right here. So let's pick a couple of random points. The easiest one to pick is always 0, 0. So I'm going to pick 0, 0 right here. That means I'm going to plug in 0 for y and 0 for x. Is 0 less than or equal to 2? Yes, that's true. Okay, so that point checks out. Let's try a few more so we can get the idea. I'm going to let's pick this point up here, which is 4, 4. So when I plug in 4 for y and 4 for x, is 4 less than or equal to 6? Yes, that's true. All right, let's try one down here in the negative zone. Let's go with 3, negative 2. So when x is 3, y is negative 2. All right, so when x is 3, y is negative 2. And 2 is less than or equal to 5. That checks. 2 is less than or equal to 5. Let's try one more down here in the double negative zone, where x is negative 2 and y is negative 2. They're both negative 2. Negative 2 less than or equal to negative 2 plus 2. Negative 2 less than or equal to negative 2 plus 2 is 0, and negative 2 is less than 0. All right, I've checked 4 different points here, and all of them made the equation true. So here's the thing. I could pick any point over here. Any of these points, even if it's not in the grid, even if they're fractions, I could pick any point over here and plug in the coordinates, the x and y coordinates of that point, and it would make that equation true. All right, let's talk about the points on the line. Okay, this particular graph has a less than or equal to sign, which means I can also include the points that are on the line. Okay, so I'm going to try a few of those points. When x is negative 1, y is 1. Let's see if that makes the equation true. When y is 1 and x is negative 1, 1 is less than or equal to negative 1 plus 2 is positive 1. Okay, so while 1 is not less than 1, it is equal to 1, so that is why I can count that point. I can count any point on that solid line. Let's try another one. All right, let's try this one at x is 0, y is 2. So when I plug in 2 for y and 0 for x, 2 less than or equal to 2. That also checks because 2 is equal to 2, so I can use that point as well. So when you have a solid line, you can use all of the points on the line, and any of the points in the shaded area would also be solutions. So any point that is on the line or any point in the shaded area will make the equation true. All right, steps to graphing a linear inequality. I need you to pause the video for a minute and write these steps in your notes. Okay, so yesterday we learned how to find the shading in Desmos, but there is an algebraic way to find the solution area, or which side you're supposed to shade, and that's what we need to take care of today. So we're going to do the same thing we did yesterday pretty much, except we're going to add a little step. So if I'm going to graph this equation here, I still have to solve for y. So I'm going to box in my y term, because that's the thing that has to stay there, which means I'm going to have to subtract x from both sides. And of course my x's will cancel on the left, leaving me negative 2y equals negative x plus 6. All right, looks like I'm going to have to divide now by negative 2. Before I do that, I'm going to slip a little 1 in here, because I can see that when I divide by negative 2, it's going to give me a fraction. So I just want to know what kind of fraction I'm dealing with here. All right, so y is going to be equal to 1/2 x, positive 1/2 x, minus 3. All right, so far I'm just graphing a line. Okay, so y equals 1/2 x minus 3. I have a y-intercept of negative 3, and I have a slope of up 1 over 2. So up 1 over 2, excuse me, up 1 over 2, up 1 over 2. All right, so there's my line. Let's say that instead of an equal sign here, let's say that I had an inequality symbol. Oh, let's just say it said less than or equal to 6. So now because I have the inequality symbol, I'm going to have to do some shading on my graph. And the big question is, what side of the graph do I need to shade? Do I shade above the line, or do I shade below the line? All right, well, yesterday we learned that you can shade below the line if it's less than and above the line if it's greater than, but sometimes it's really hard to tell which way is above the line and which way is below the line, so we have to have a surefire method of determining which side to shade. So what you're going to do is you're going to pick a test point and try to pick 0, 0 if you can. It's the easiest point to plug in. If you can pick 0, 0, a lot of neat little things happen up here with your equation, and it makes your life a lot easier. So I'm going to be plugging in that point right there, the origin. So my test point is 0, 0. That means I'm going to plug in 0 for y, and I'm sorry, 0 for x and 0 for y, and see if that makes my equation true. So 0 minus, that also becomes 0, 2 times 0, 0, less than or equal to 6. Is 0 less than or equal to 6? Well, of course, 0 is less than 6. That is a true statement. So since the 0, 0, let me get my highlighter going here. Since 0, 0 is on this side of the line, that's the side that I have to shade. So all of these points up here that are on this side of the line are solutions to this graph. For example, I could say that's a solution, even way up here, because that shading is going to extend all the way up infinitely. And it's going to keep going. All right, so we are naming 3 solutions. All right, let's name 3 solutions. All right, so 3 solutions would be any 3 xy points that are in my shaded area. So I'm going to pick, I already picked a couple here. That's negative 3, 0. And let's pick another one. Let's go back. We already picked the origin. Let's include that one. And then let's pick one over here. Let's say negative 10, negative 3. Again, there's an infinite number of solutions you can pick. They're everywhere. Solutions all over the place in here. Okay, next part of the problem says, oh, let's wait. Let's pick one that's on the line too, because I have the greater than or equal to symbol, I can pick one that is actually on the line. So I'm going to go and pick that one, which is the y-intercept. And at the y-intercept, x is 0, y is negative 3. So I actually named 4. All right, let's pick 3 non-solutions. So I'm going to pick a non-solution. I can pick anywhere on the other side. So all of my non-solutions are going to be on this side of the line. So any xy point that I pick on that side of the line is going to be a non-solution. So let's just pick 3. I like that one. X is 10, y is 0. Let's pick one down here. I got x is 0, y is 1, 2, 3, 4, 5, 6, 7, 8. 0, negative 8. And then let's pick this guy right here. X is 4, y is negative 4. Okay, so again, just to reiterate, solutions of linear inequalities have an infinite number of solutions, but the plane is cut in half by the line. One half of the plane, or one side of the line will have all the solutions. The other side of the line has no solutions in it. All right, let's try this guy. So let me fix my board here for a sec. All right, here we go. I had to get all this stuff so you could see it. All right, so first thing you got to do is solve for y. This guy's going to stay here. I'm going to have to add 6x to both sides. That is going to leave me negative 2y equals 6x minus 8. And then when I divide everything by negative 2, that's going to leave me sorry about that. That's going to give me y equals negative 3x plus 4. Okay, negative 3x plus 4. So I'm going to erase this right here just so I have some room. Y equals negative 3x plus 4. All right, so I'm going to go ahead and make this an inequality because I think we're past graphing equations. So instead of the equal sign, I'm going to make that a less than sign. Okay, so let's change this to a less than sign. So go ahead and erase your equal sign and put a less than sign there. All right, so first thing we have to do is graph the line. Okay, y-intercept of positive 4, 1, 2, 3, 4. There's my y-intercept. And I have a slope of negative 3 over 1. So down 3 over 1, down 3 over 1, down 3 over 1. So here's my line. Okay, so you're probably noticing that I made a mistake. Did you catch my mistake? My mistake is this is a less than sign. It does not have an equal to sign underneath it, so my line should actually not be a solid line. My line needs to be a dashed line. So I'm going to go ahead and fix that. Get rid of all this little stuff here. Okay, so since I have it less than, it has to be dashed. Okay, so hard to see which is below and above the line on this one, so I'm going to use my test point, and test point of choice is always 0, 0, so I'm going to plug 0 in for my equation. So if I plug in, here's my equation, y is less than negative 3x plus 4. If I plug in 0 for y and 0 for x, that's going to give me 0 is less than 4. Okay, so since my 0, 0 point works, because 0 is less than 4, I am going to shade the side of the line that 0, 0 is on, which is on this side. Okay, so the last part of my problem says, name 3 solutions. So I can pick any 3 points that are in the shaded area. So I'm just going to pick 3 random ones. Negative 2, 0. I can pick negative 1, negative 1. And I could pick, let's pick this guy right here, negative, or 0, negative 3. Now be careful with this, because when you have a dotted line, you can no longer pick a point down the line to make the equation true. So I want to point that out to you. We're going to try one so I can prove it to you. So let's pick this point right here, the y-intercept. When x is 0, y is 4. So my equation is, again, y is less than negative 3x plus 4. If I plug in 4 for y, and 0 for x, 4 is less than 3. Negative 3 times 0 is 0, so I get 4 is less than 4. So this is not true now, because 4 is not less than 4. 4 is equal to 4. So before, when we had this little thing going on, it was okay to use 4, but when that's not there, you can't use 4. So no points on the line are going to be solutions. All right, name 3 non-solutions. Easy peasy, just go to the unshaded area and pick 3 points. Let's pick this one right here, 3, 2. And let's go with that one, 5, 0. And all I need is one more. Let's go with 2, 3. Again, for a non-solution, I could have picked up here, could have picked over here. As long as the point is not in the shaded area, I can pick whatever point I want. So solutions are in the shaded area, non-solutions not in the shaded area. All right, I'm going to do one more example because I want to show you what happens when your 0, 0 test point does not work when you plug it back in. So let's see what that looks like. So first thing I'm going to do is I'm going to subtract x from both sides because my negative 2y has to stay here. That's going to leave me negative 2y greater than 6 minus x. Oops, let's go ahead and switch that around first. Okay, negative x plus 6. And then I think I'm going to slip my 1 in here while I'm at it. All right, going to divide both sides by negative 2. Okay, now don't forget here, when you divide by a negative number and you're dealing with an inequality, you have to flip the inequality sign. So this equation now becomes y is less than 1/2 x minus 3. All right, let's go ahead and graph our lines. So I have a y-intercept of negative 3. And I have a slope of up 1 over 2. So up 1 over 2, up 1 over 2, up 1 over 2. And because it's a less than symbol, I'm going to have a dotted line. So let's see if I can do a dotted line here. All right, so now my line is graphed. I have to figure out where to shade. So 0, 0 is not on the line, so that's the point I'm going to check. My test point is 0, 0. So when I plug 0, 0, let's write my equation over here. I'm kind of running out of room. Y is less than 1/2 x minus 3. Plugging in 0 for y and 0 for x. That gives me 0 is less than negative 3. Well, if you think about your number line, 0's here, negative 3 is over here. It goes from small to big. 0 is bigger than negative 3. 0 is greater than negative 3. So this is false. This is a false statement. Okay? So since 0, 0 did not work, I can't shade the side of the line that 0, 0 is on. I have to shade the other side of the line. So instead of shading where the 0, 0 is now, I have to shade on the opposite side. So I have to shade over here because 0, 0 did not work. Okay, so now I can name 3 solutions. I could pick any 3 down here. Let's pick this one at negative 2, I'm sorry, 2, 4, negative 4. Let's pick one over here. That is going to be 1, 2, 3, 4, 5, 6, 7. 7, negative 1. And let's pick this one down here. Negative 10, negative 10. Okay, those are my 3 solutions. 3 non-solutions would be 0, 0. 0, 0. Let's go backwards this way. Negative 2, 0. And let's pick this guy over here. 1, 2, 3, 4, 5, 0. Okay, so when your test point doesn't work, you shade the other side of the line. Okay, at the bottom of your notes, or at the end of your notes, I want you to name 3 things that you're going to remember about shading inequalities or graphing inequalities, and then I want you to do the worksheet after you're done. Have a great day.